So yeah, guys, welcome to you all. So first of all, who the hell am I? My name is Duarte. It's like do and then art. I'm originally from Lisbon, Portugal, but I'm based in Copenhagen, Denmark. I also like running a lot. I run like 3 marathons every year. It's an okay addiction. I think it won't last long. Sono ancora imparando l'italiano, la mia ragazza è d'Ancona, marchigiana. Il mio italiano non è così buono, ma parlo un po'. Okay, in the past I worked in strategy, product management, new ventures, management consulting. So I've been around a couple of positions. Currently, I'm a ML engineer at Ample Market, also a contractor. But one thing that has always stuck with me throughout the years is Python. Well, computers in general, actually. Even when I was in product management or strategy, I was actually using Python to like run scripts to do M&A analysis on competitors, or I was running scripts to scrape off competitors and send emails and stuff like that. So wherever I was, what type of position it is, even before being a machine learning engineer, I was writing a lot of code. Maybe I shouldn't, but I really like it, so I've been doing it. I also wanted to take a moment to thank Ample Market. It's kind of the main place where I'm working right now. It's an incredible, amazing team. Like I really enjoy working with smart people. I like being like the dumbest guy in the room all the time. And at Ample Market, that's really what's happening. So here's some of the people team. We get really close. We're distributed completely remote in the US, Portugal, Denmark, Germany, throughout Europe. And yeah, we're also hiring, so if you're interested. Yeah, unfortunately, this is not a technical talk. I really like code. I really like getting into the nitty-gritty of all of the different code and all the libraries and frameworks, but it's not a technical talk. So if you have under 4 years of experience writing Python, this will hopefully tell you like how to be a better dev in Python. It also teaches you some tips and tricks, and it's a lot of opinionated advice. I have strong opinions about almost all the things I'm going to talk about, so it's completely fine if you have a different opinion. I'm just very opinionated. If you are very experienced with Python, then we're gonna take some time to reminisce, also celebrate the fact that we're here today, and also it's a reminder for you to really stay intentional with the stuff that we're doing. If you've been writing code for 5-10 years, like it's a reminder for you to think about these things that maybe you don't even think about them, but a reminder to you keep that radar open for these things. And yeah, let's go. So the first lesson that I've learned is that reading is much better than Googling. And I've been a software engineer. This is my code editor. I use Vim. I have a very love-hate relationship with Vim. I hate it. I think it's I spend my time customizing it, but I really love it. So it's a weird relationship. And when we start writing code, we actually think that we have these superpowers, right? We can write whatever comes to place, automate all the things. And we have autocomplete, so it really helps us find out the libraries that we want to use. Like we know what function takes in, what function gives out. We also Google a lot. Like we all have this thing, maybe it's just me, but we all have this one thing that we Google every time. I Google it, for me I have a couple of things like, if, for, else, list comprehension. I always Google it. I have no clue how it's written. We also have Stack Overflow, right? So it always comes to the rescue in case anything is there. You can always copy paste. And it seems like you have Python, right? You have this massive hammer and everything is like a nail. You just bam, bam, like write all the code. And you pip install everything. Pip install the world. Your requirements file looks like a mess. You've been evaluating like how to manage these dependencies. But the thing is that when you actually Google all these things, you start forgetting things really quickly. You start realizing that you're Googling these things maybe a bit too much, and you're not like interiorizing or like taking in like the things that you're reading. And I learned this lesson actually when I was using this horrible editor called Vim, that out of the box has no autocomplete. So I was just using like, I was just writing it. Maybe NeoVim now has autocomplete, but at the time it didn't. And so I was just like, reading. And I started reading. I actually started like taking a closer look at the pandas documentation, for example. And I mean, it's quite a work of art. Like, it's so well documented. Like, everything is so neatly described that once you start reading things, you start understanding what it really does. This thing actually does a little bit more than what I expected. This sklearn algorithm, or this this scikit function, actually does a lot of things that I didn't know about, that I was actually writing some custom code for. And you actually start thinking that there's a lot of options. Maybe the defaults don't really work for you sometimes. So now that you're reading the function and reading its documentation, you start understanding what it does really. And also, like, there's a lot of default behaviors out there. Like, we work with tools that are very powerful, and there's a lot of default arguments in all of these tools. And are the default arguments really what you should be using? Or should you actually know what those default arguments are? And yes, I'm talking especially about machine learning frameworks and libraries. And if you start reading and really understanding these functions, you start understanding that maybe you can reuse these things somewhere else. Maybe you can, like, maybe this function does more than you expect. Maybe you can reuse it somewhere else. And for the first time, it actually sticks. So you actually know this function, and next time you probably won't Google it because you've read about it and it's now in your brain, and you can actually come back to it and just reuse it. And this came to me with the, I don't know if it's famous, but for me it's famous, the pandas data frame, the drop NA function, where everyone that I've seen that starts coding is like, oh, but I did the drop NA and it's returning a none. And I'm like, yes, because you have the in place argument. And so just start reading the functions and start reading the docs. It will really help you out. All right, second thing is explicit is better than implicit. Yeah, I've been here a lot of times. I know that I can make this program shorter. I know that I can write in a couple of lines of code rather than like 100 lines of code. We're always in this thing of like, yes, I can be faster. I can be short, I can be more concise, but then this happens. then you're writing this weird thing that nobody really understands what it is or how to read it. This is actually from an advent of code that a guy that did all the advents of code last year using single lines of Python code. I don't know why you would do this to yourself. Yeah, we have this thing that less lines equals better code, right? Like, yeah, like we're good devs, we can write it shorter. And then like we have these list comprehensions that I still, guys, I struggle with these. And then you start hearing things like scheduler, state machine, abstract controller, operator. And when normally people start using all of these weird terms, for me it's always a stop. Like, I mean, what are we really talking about here? Are you sure you want to go into that level of complexity? Most of the times, no, is the answer. This is just a reference from a book that I read recently called Practices of the Python Pro, which talks a little bit about what is good code. And it explains that on the top, like that good code is code that is extensible. Code that when you start writing and you want to add on top of it, you just add on top of it. It's like really extensible code. Instead of those programs that we sometimes write, I'm sure everyone here has written one of them, where when you have to make a change, you shotgun the entire code. You're like changing there line 5, changing line 10, changing line 12, changing this variable name, and that's much less extensible code. That makes you have a lot more work, and I'm a bit lazy, so I don't like to write that type of code. So what is actually better code? It's not less lines. It's a couple of things in my understanding. Code is it's code that's readable, that you can read upon. It's code that is understandable. It's changeable, so you can add on top of it. It's shareable, so if you pass that code to a colleague, he doesn't need to have 3 meetings with you asking you about every certain variable. You can read what the variable actually does in its name. And it's code that it's enjoyable to read. The more time I code and I'm in this job or this skill or this craft, the more I read code. And some code is really enjoyable to read. And if someone comes to me and says, Duarte, like, I mean, I really liked your program, like I enjoyed reading it. I'm like, oh yeah, this was a like job well done. It doesn't really matter for me how many lines I run. This is a really good book actually that tells you, has a whole section on how to name variables, which is something that we actually overlook a lot of the times, but it's something that is really, really important. So yeah, first make it work, then make it pretty. This is an example or a situation where I was actually interning in the US, in Boston. And I remember I was making this program that like analyzes all of the potential people that we're going to sell to in our radius, and then there's an algorithm that ranks those people and who we should reach out to first to sell our product. It was a really cool algorithm. I was super excited. I was talking to my manager saying like, yeah, like, I mean, we have to consider all of these cases. And he was like, yeah, Duarte, like, first make it work, then we'll talk about it. And I was like, okay, that's actually a good point. It doesn't work yet. So maybe I should focus on making it work rather than making it pretty. And I also have this other story about a case where I was working at a client, and he said, yeah, we're going to build this data management framework. It's everything that like everyone that wants to manage data here gets into our program. It manages all of the data pipelines. People don't have to do anything. And you just write all the code, and all the code is completely automated. And I said, like, let's not do it. It sounds like we're reinventing the wheel here. And the vendor that we talked to on the platform we were building, he was like, guys, do not do it. Like, this is not designed to write code that way. And the partners were saying, don't do it. Like, it has been written before. The client doesn't advise it. Why are you doing it? We still did it because there was a stubborn engineer there. And I hope it went well. I'm pretty sure it did not went well. Reinventing the wheel normally does not go well. And that's why I call the data management framework, AKA reinventing the wheel. So when you start hearing about these management frameworks, heads up. It's gonna go wild. So yeah, first make it work, then make it pretty. Start by writing the bare minimum. Like, what is the bare minimum thing that you need to write to make your program work and that you can test it with your users? Then catching all of these exceptions, catching all exceptions is like catching all Pokemon. It's never gonna work. So catch the exceptions that matter, that will hit the user. And 100% code coverage. I'm sure we all are big fans of code coverage, but 100% code coverage, let me remind you, does not guarantee 0 bugs. Okay? So you can do all the code coverage that you want, you're just gonna still probably have bugs. And that super weird edge case that you're thinking about of that algorithm that might happen in like 2% of cases, I mean, don't do it. Because think, do users care? Is this 2% worth the investment of your entire day of programming for something that has a 1% chance of happening? I mean, if it happens, it happens. You'll fix it, right? I mean, it's not a problem. So think about, do users care? And most of all, when I've looked at senior devs and people who are much smarter than me, I actually always know that they are good devs because they know what code not to write. It's not about knowing what code to write. It's knowing exactly about things that you need to just step away, like just not write them. And that's a really important skill, in my opinion. I have a whole rant about like simple software. There's the link if you're interested. Yeah, the other advice is test early and test often. Yeah, tests are a mirage. The projects that I've seen, maybe I'm an outlier, I could be, but 80% of the projects that I've seen when I'm coming in, they do not have tests. Like, people don't write them because their value is not that obvious, right? I mean, if you go to your manager or some manager and say, like, I'm going to spend 2 days testing this, and he's like, yeah, I mean, what are my users going to see? Nothing. So it can really not matter that much. The value is not obvious, and users don't see them, and bugs can still happen even if you do unit test. So what's the real value of them? First of all, I mean, if 80% of people don't do something, it's a good indicator that maybe you should do that thing, right? Do not follow what everyone else is doing. Not everyone comes to PyCon Italia, I'm sure, so yeah. And tests, at least for me, allow me to deploy with more confidence. Allow me to know that the function that I wrote actually does what it's supposed to do. So maybe I don't test all the functions, but maybe only the ones that I'm actually a bit, uneasy about, and I want to make sure it works. And yeah, users don't see them. What if the app goes down? I'm sure they'll see then if the app doesn't work. And most of all, tests are about minimizing. It's about minimizing something, right? They're eliminating. You're not going to eliminate all the bugs. It's about minimizing the chances of them happening. So keep that in mind. And my last point is continuously learn. So a thing that I carry, and here I'm in PyCon, like I really love Python. I'm sure most of you guys here probably love it too. It's that Python is our craft. So we're craftsmen, and it's our job. It's the tool we use. And one of the things I like about PyCon is that I can now listen to me, and then I'll be listening to some data stuff, and I'll listen to some web stuff, and I can listen to all of the different things, but it's all about Python. And it is our craft. Yeah, these are 3 pictures. It's on the left side is my dad and my little sister. They're actually doctors. My little sister's studying to be a doctor. My dad's been a doctor for a long time. He's always been to conferences all of his life, always spends his Sunday last a couple of hours studying like what the new techniques, new surgeries he can develop. My little sister's kind of following his footsteps, and she really studies now and really tries to get better what she's doing. She's going to a couple of conferences, and that's the feeling that I carry also for me. Like, I mean, they're doctors and that's their craft, but for me, Python is my craft. It's the tool I use. Like, you're using your surgery skills, I'm using my programming skills to become better at it. So I really am proud of that. So for me, a conference it's me trying to get better in my field. And that's the sentiment I like. The middle picture is my grandpa. A lot of the side of my mom, they're mostly geologists and geographers. And here, I don't know if you can see it, but he's saying normal fault, like the geological fault. And here is the engineering fault, and he has like a cross arrow to kill. He doesn't really like me being an engineer. He's a scientist, but yeah, this is what it is. And he's really good at what he does. Like, he's been teaching for a long time, has a couple of books on geology. Here's his house. It's a mess. It has books everywhere. He spends a lot of time studying, but it's really a feeling that I also have for me and my work, is that maybe I don't want to go to this level of fanatic, but I am fanatic about the work I do. I really enjoy doing it well, and I take great pride in that, and I think you guys should do too. If you're doing something, like, really take pride in it, take time to get better at it. So we should be masters of our craft. Python is our craft. So study, stay up to date, also learn regularly, like take time to learn what's the next best thing. Build things, like build things. It doesn't need to be a data pipeline on Airflow. It can be whatever. It can be managing your finances. It can be whatever program to automate sending text messages to your girlfriend. I don't care, but anything that you write helps you. And then, yeah, give back and write about what you learned. And these are some of the resources I use. And yeah, that's about it. Thanks a lot, guys.
Thank you, Duarte. That was a very insightful presentation. So we only have one question on Slido, but if anybody else has a question, feel free to raise up your hand. All right, I will read out the question. When the team needs to build and iterate quickly, Googling seems to be the best way to go. How do we factor in reading here?
Sorry, can I read it here? Yeah, I mean, if you need to build something quickly, there's this weird thing about it needs to be fast or it needs to be good. I've been working under pressure for a while, like working in management consulting for a year or so, like working 14 hours a day, and we need to do things very quickly. If you didn't need to do it quickly, deliver it. I mean, next project you'll come into, if you have more time to really do it well, then you'll get time to study it. My point here is that there's no problem about Googling. My point here is that if you take the time to read, and if you have that time to read, you'll certainly learn much more. And that's the whole point. So if you have to Google away. It's a good thing.
Thank you. So we have another question now. Which were your main roadblocks in your Python journey?
I would say mostly imposter syndrome. I think there's a lot of us that struggle with it. We think like, yeah, like look at all of these crazy guys that do incredible open source projects. Like you're here writing your script or your package, and you have these guys that developed Airflow or developed Scikit, and you're thinking like, I really suck. You don't suck, okay? Like everyone has that feeling. It's normal, and I have it also. And even when they ask me to come and talk to PyCon Italia, I still think like maybe they made a mistake. Maybe I don't really belong here. So I mean, just ignore it. You're really good. So focus on that.
Thank you very much for that. Yeah. So that's all the questions for now. You could always catch up with the speaker if you want to. All right, a round of applause for Duarte once more.